Welcome back everyone. We can discuss about next type of canonical form, that is product of sum. We can also call it as pos. So in our previous video we have already learned about our SOAP form. The SOAP form are actually the sum of minterms. The minterms are generated by combining two or more variables using logical AND operation. And we can generate different minterms. Such minterms are combined using logical OR operation, and we can generate canonical SOAP form, sum of product terms. And here we are going to discuss about POS form, product of sum terms. These sum terms are also called as max terms. Max terms or standard sum terms. How to generate this max term? The max terms are generated using or combining two or more variables using logical OR operation. Okay, just compare these two and understand the difference. Max term means combining two or more variables using logical OR operation. Okay, minterm means combining two or more variables using logical AND operation. Similar to this, here we have the max terms generated by combining variables using logical OR operation. This can also be called as standard sum terms. Okay, so consider two variables x and y and combine using this logical OR operation. Then what are the possible max terms here? This x plus y complement, x complement plus y, x complement plus y complement. Okay, so combining these max terms using logical AND operation, we get product of sum terms, POS form. Okay, so here just revise this table again. In min terms, here we are combining variables in its original or its complemented form using logical AND operation. And if the value of the variables are equal to 0, then in min terms, we can use complemented form of the variable. If the value of the variable is 1, then use the variable's original form. Right. So here in max terms, what is the difference? In order to represent max terms, we use this logical OR operation for combining these variables. And if the value of the variables are 0, then in max terms, we use the variable's original form. Means if x equal to 0 and y equal to 0, we can generate a max term like this, x plus y. Variable's value equal to 0, then use the original form of the variable. If the value of the variable equal to 1, then use the complemented form. Here both x and y are 1, then the corresponding max term is x complement plus y complement. If x is 1 with y is 0, then the max term corresponding to this particular x and y is x complement plus y. X with value 1 and y with value 0. That is why x is used or represented here using complemented form and y is represented using its original form because value of y is 0. Okay. So next is about canonical POS form. Product of max terms or product of standard sum terms. How to generate this canonical POS form? Consider this table, truth table using three input variables PQR, and different possible values are listed here, and the function output of this particular truth table is given like this. Okay, so here for different input combinations, the F output becomes 0 somewhere and 1 somewhere. For generating the POS form, canonical POS form, we need to consider the output value which is equal to 0. Okay, so for here, for 4 different input combination, the output value becomes 0 here. What are the 4 input combination corresponding to that? The output becomes 0 here. For this, P with 0, Q with 0, R with 0, the output is 0. Here again, P with 0, Q with 0, R with 1, output is 0. Here again P is 0, Q with 1 and R is 0, the output is 1. Sorry, output is 0. And here P is 1, Q is 0, R is 0, output is 0. So for generating the canonical pause form, we need to consider the input combination corresponding to the output whose value is equal to 0. But in our previous case, that is for canonical swap form generation, we need to consider the input combination corresponding to which the output value become 1. So here just the reverse, or just not the reverse, just the opposite. That is, for the output value equal to 0, we need to consider the corresponding input combination here. So here for 4 combination, we have output equal to 0. So what are the max terms here? We need to generate one max term using this combination, another using this combination, another using this, and the fourth one using this. And how to write the max combination? If the variable value equal to 0, then use its original form. Variable's original form. If the variable value equal to 1, then use the complemented form of the variable. And we can combine different variable using logical OR operation in order to generate the max terms. So using these particular variable values, we can generate a max term like this: P plus Q plus R. And for this, P plus Q plus R complement. Corresponding to this output, we can generate a max term P plus Q complement plus R. And corresponding to this 0 output, we can generate the fourth max term, that is P complement Q R. Sorry, P complement plus Q plus R. Combine the variable using logical OR operation. So using these max terms, we can generate the canonical pause form like this. By combining these max terms using logical AND operation in order to generate the canonical pause form or the standard pause form like this. The function is now represented in pause form like this: P plus Q plus R and P plus Q plus R complement and P plus Q complement plus R and P complement plus Q plus R. Okay, it can be represented in another form like this with the help of this value. This can be represented using this particular representation, capital M0. Max term 0, max term 1, max term 2, 3, 4, 5, 6, 7. Using this representation, we can introduce a new representation form, the canonical pause form like this. For this particular M0, output is 0. So, M0 and M1 and M2 and M4. Another one more representation, that is using this pi. That pi indicate product or logical AND operation. Okay, what are the terms we need to AND here? The M0, M1, M2 and M4. So this is another valid representation for this canonical pause form. 3 different representation for the same pause form. Okay. Next is about the minimal pause form generation. What is this minimal pause form? Minimal pause form contains minimum sum terms with minimum literals as possible. That also give the complete information as the standard pause form gives. We need sometimes if you are given with a standard canonical pause form, sometimes we can reduce the number of sum terms in it. And also we can reduce certain literals or the variables present in the sum terms. And when generate a smaller representation for the given canonical form. But the meaning of the reduced form is exactly matching with the meaning of our given standard form. Such a representation is called minimal pause form. Okay, so how to generate minimal pause form? Consider one simple example using two variables P and Q. Okay, and the output is like this. For these two variable value with 0 0 output is 1, and for this 0 1 output becomes 0, 1 0 output become 1, 1 1 output is 0. And for the generation of post representation we need to consider the output with value 0. So these are the two input combination to which the output value becomes 0. This one and this one. Okay. So now we can represent this function f using pos form is like this. P plus q complement and p complement plus q complement. Okay. Now we can try to minimize this. For the minimization, just analyze the two max terms present here in this function, in which q dash is common. Q dash is present in this max term and q dash is again present in this max term. Okay, so now this particular distributive law, what is it? A dot B plus C is A dot B plus A dot C, and similarly A plus B dot C is A plus B dot A plus C. Okay, so this is actually of the form this A plus B dot A plus C. P plus Q complement dot P complement plus Q. From this, we can write like this. That is, take the common part outside. Q complement is common here. So, Q complement plus the remaining part using logical AND operation. That is, P dot P complement. Okay, and using this complement law, we know that this a variable and its complement is 0 actually. So we can substitute 0 for this P and P complement. So the minimized form of this particular standard pos form is Q dash or Q complement. Okay, so following this distributive law and complement law, we can simplify this given standard pos form and we can generate the minimal pos form. Consider one more example for understanding this minimization of pos form. Minimization of standard pos form. Okay. So consider this particular canonical pos form which is given here. The function is represented using three variables a, b, c, and the max terms are like a plus b plus c, a plus b plus c complement, a plus b complement plus c complement. They are connected using logical AND operation and generate the standard pos form, canonical pos form. Okay, now consider these two terms, these two max terms. Okay, here this a plus b is common. So by following this distributive law, we can take the common term outside, that is a plus b together outside, plus c and c complement based on these. These two terms are of the form a plus b dot a plus c. So using this we can write like this, a plus the common term plus the remaining term using AND operation. That is a plus b is common here. So a plus b plus c and c complement. And this term write as it is here. So from the complement law, we know that this particular form, a variable and its complemented form equal to 0. That is a plus b plus 0 dot this. Okay, that means a plus b dot, we can avoid the 0 and rewrite like this. Now consider these two terms. Here a is common, right? So again apply this distributive law, take the a outside, the common part outside, a plus the remaining part is b dot, here b complement plus c complement. Common part outside plus the remaining part using logical AND operation, right? So a is common here, a plus, here it is left with b. So b dot B complement plus C complement. We can apply this distribute law here, that is now it become A plus B dot B complement plus B dot C complement. This term become 0 using this complement law, that is A plus B dot C complement. That is this. This is of the form A plus B complement C dash is of the form A plus B dot C, which is equal to A plus B dot A plus C complement. So this is the final minimized form of our given post form. Okay. Next is converting a given minimized post form back into its standard or canonical post form. How it possible? So this is one example, given function f with three variables a, b and c. And the form is like this. The post form is like this, a and a plus c. So this is not in the standard form. In standard form or the canonical form, we have all the variables in it. But here with different max terms. Here we have two max terms, one with a alone and the second with a plus c. Here b part and c part is absent. Here in this b part is absent. In order to make it in a standard form, we need to consider the remaining variables with each and every these max terms. We need to consider different variables in its original or in its complemented form. But here A alone is present. B and C in its different form is not present. Here B or its complement form is not present. Okay. How we can consider or combine the other missing variable with these max terms? For that again we need to consider these laws. This A, how to make this A into its standard form? We can combine this A with B and B complement. From this it is clear that B and B complement is equal to 0. So A plus B and B complement, this is actually equal to A plus 0. Equivalent to this by adding 0 with A. Okay, now we can apply this rule, distributive law over these, and generate this as A plus B and A plus B complement. Okay, so now this A become a term having two variables A and B. Now we need to make the term containing C also. For that we need to consider along with this term, that is C dot C complement. This is actually equivalent to value 0. So we can directly add C and C complement with this term. Add means logical OR operation with this term. Again apply this distributive law over this. Now it become A plus B plus C. Next A plus B complement plus C. Next A plus B plus C complement. Next A plus B complement plus C complement. 4 different forms. Okay, so along with this A, now we are added B part and C part. So now we get a standard pause form for this A, the first product term, max term. Now it is converted like this. And for this here B part is absent. Now in order to make this in its standard form, what we want to consider? We need to consider the B part. That is, we need to add B complement with this. B and B complement with this. Then apply this law. Now it become A plus B plus C and A plus B complement plus C. Okay. Now consider these terms and these terms and rewrite. Here A plus B plus C is present here. again a plus b plus c is present. We need to write only once the repeating term in our standard form. So write only once this a plus b plus c here and a plus b complement plus c, which is again repeating. So write only once. This a plus b plus c complement, write as it is here, and again a plus b complement plus c complement. So this is actually our this is actually our standard POS form, which is derived from this given minimized form. Okay. One more example. So students, please stop here, pause the video and try to generate the standard POS form by yourself. Okay. After that, check the answer. So the question is like this. A and A plus C complement and A plus B. So in our first first max term, the sum term, here A is alone present, B part and C part is absent. And in the second sum term, B part is absent, and in the third sum term, C part is absent. So consider each term separately. The first part become A plus B complement plus C complement. And second part become A plus B complement plus C complement. Third sum term become A plus B plus C complement. So consider this, convert this like this, A plus B plus C, then A plus B plus C complement and A plus B complement plus C and A plus B complement plus C complement. Next, this term. This can be converted using our distributive law. A plus B complement plus C complement is equal to A plus B plus C complement and A plus B complement plus C complement. The last term, last sum term can be converted like this. A plus B plus C complement is equal to A plus B plus C and A plus B plus C complement. Now combine these three generated terms together and avoid the repeating term. A plus B plus C, A plus B plus C complement and A B complement plus C and A plus B complement plus C complement. Here this is already written here, so we don't want to repeat it again. This term A plus B complement plus C complement already written here, so we don't want to repeat it again. And here A plus B plus C is already present here, then A plus B plus C complement already present here. So this is the standard POS form for the given minimized form. Okay, thank you.